In this lecture, we will learn how to define time history functions. To do that, we go to Define, Functions. Here you will find two options, that is response spectrum and time history. We left click on time history. Define time history functions window will open. Here you will find various options and some predefined time history functions. This is the number one option, that is we can either add the functions from file, we can either add the function from user, or we can add a sine function, cosine function, ramp function, sawtooth function, triangular, user periodic, or match to response spectrum time history functions. So first of all, we can go ahead with sine functions. We select the function as sine, we left click again on add new function. Here you will notice that sine curve is formed. So we can adjust the period, number of steps per cycle, number of cycles, and amplitude according to our requirements. So we can change the parameters. For example, let it the number of steps per cycle can be, for example, 15. Number of cycles can be, for example, 10. See, as per the number of cycles, this graph will automatically get changed. And amplitude can be maximum, now it is 1, but it can be, for example, 2. So you will see here that initially it was around at 1, but now it is at 2. And accordingly, this window will automatically get changed. You don't need to update it. You need to enter data in all these four options. Or if we want to enter the data here, then we can left click on convert to user defined. Now you can enter the data here as per your requirements. So now this function 1, that is sine function, is now defined. Second option here is cosine function. Here you will notice that this function is now cosine, as its start is from 1 and end at also 1. We can adjust the number of steps per cycle, number of cycles, amplitude, again as per the what we had done with the sine function. So now we have defined a sample cosine function. Then we move on again to ramp function. In ramp function, what exactly happens is that the graph is something like this. So ramp time, let it be number 2, amplitude let it be 5, and maximum time let it be 30. So now we have defined a ramp function. Similar is the case with convert to user defined, that is if you want to enter the user data, that is time and value, manually, we can also do that. So after ramp, we can go ahead with sawtooth function. So this type of function is called sawtooth function. Again, convert to user defined option is available. After that, we can go ahead with triangular function. We again left click on add new function, and then we will sign in the period, number of cycles, amplitude. Again, like convert user defined option is available, and this option can automatically get changed as per our input. That is, number of cycle can be, for example, 10, amplitude can be maximum 2, 5, and period can be, for example, 2. So all this data automatically gets updated, and similarly this graph also automatically gets updated. You will notice that as when you move your cursor over this, so whatever is the coordinate, it will automatically get seen here. So the graph value of this blue dot is automatically getting updated in this option here. So again, we left click on OK. So this function 4 now is also defined. After that, we can go ahead with user periodic. That is, we can enter the data from 0. We need to enter all the data here, and then we again, for example, let the time be 0, let the value be 4. We enter the value here. Let the time be 2, value be 7. We again left click here. So as per this data, we can also add the user periodic function. After that, we can also add match to response spectrum function. What exactly happens is that is we can set the target response spectrum, response acceleration, time history. That is, input is this option and output is this option. And we can also change the response spectrum plot axis option. That is, we can go ahead with x linear, y linear, x linear, y log, x log, y linear, and x log, y log. So all this data can be entered as per the user requirements. So when we left click on match time history, this graph automatically gets updated, and then we can check here by left clicking on show frequency content. On the left, you will find a frequency content of reference time history. On the right, you will find a frequency content of match time history. And we can also change the plot axis option, that is x log, y log, x log, y linear, x linear y log and x linear y linear. So as per our user requirements or as per what exactly we are trying to accomplish, we can change the time history as per the response spectrum. We again left click on OK. So now this function 6 is master response spectrum time history function. Here you will see that this browse option is coming. When you left click on browse option, it will go to your system. So actually what happens is that in Etabs, some predefined time history functions of various predominant earthquakes or various earthquakes which are thoroughly studied or the time histories are already prepared, Etabs was offering an option to import those time history functions in your analysis file. The syntax of our file should be, we should first go to our C drive, then we should go to our program files, computers and structures, Etabs 2016 and time history functions. Here you will see that there are various time history functions that are already predefined by Etabs program. Altadena array, correlate, El Centro, Hollister, Lexing, Lucent, Petrolia, Pomona, Monica, Oakwaf, Yermo, Silmaf. So time history functions of all these places are already predefined by Etabs. To import time history function, we can just left click on, for example, lacc_nor. We left click again on open option. Here you will see that time history function is now shown here. So we can also left click on view file option here to see the time history function in the form of MS Word file. We again left click on OK option to freeze our lacc_nor one time history functions. Here you will see that there is an option to click to view response spectrum. So the beautiful thing about Etabs is that it is also offering flexibility to us to cross check that time history functions, how the time history function is looking in the form of response spectrum function. So here you will see that it is a response spectrum plot, and on the right is a defined time history functions option. So when we left click on function 1, this is the equivalent response spectrum plot for this time history function. When we left click on cosine, this is the equivalent response spectrum function. Function 6, this is the equivalent graph, and for LACC_nor, this is the equivalent response spectrum plot, that is pseudo spectral acceleration PSA versus period second graph. Here you will see that it is also offering us the contours color, that is for blue the damping ratio is 0.02, for green the damping ratio is 0.03, similarly it goes up to blue for 0.1, that is around here. It is also offering us flexibility to change this period to frequency. See, initially it was PSA versus period, and when we left click on frequency option, it is PSA versus frequency. Similarly, we can also change the scale from linear to logarithmic, and vertical axis also from linear to logarithmic. Similarly, we can widen this spectral acceleration for our convenience, widen 15%, widen by 25%. So we have widened the graph by 25% just to so that we can study how exactly the curve is changing. We can also change the response spectrum plot option, that is plot spectrum for selected history, plot envelope spectrum for selected history, plot median spectrum for selected history, plot mean spectrum, and plot mean plus, for example, one time standard deviation spectrum for selected histories. So you can see that how much flexibility Etabs is offering us for our convenience, so that we can easily switch from response spectrum to time history and from time history to response spectrum. So we can cross check whatever time history functions we have defined here. We can easily cross check them by clicking their response spectrum plots, and then we again left click on OK option to freeze the time history functions.